So the next speaker is one of the people that I've known longest in this space. He resides in the same city as I do, and we've been dancing around each other through this interesting culture that started out with Bitcoin, and then the Riyadh Institute was the first place that Vitalik Buterin came to speak about Ethereum in the early days. And as Monero became an interesting technology, he moved into this space. He has an incredible depth of experience and research and practical hands-on hacker experience. Matthias Tarasiewicz from Vienna and Riyadh.
Thank you very much. Hey guys, thank you, Michael, for the kind words. I need to somehow bridge the gap from the last talk a little bit. So yeah, my talk is called Scaling Tech versus Scaling Values. And I will be telling you a story today about Cypherpunk and how values didn't really scale. And the tech has a solution to scale while the values are maybe still at the same position than they were in the beginning. I want to start though. How does this work actually? By introducing my institute very briefly. So I'm the co-founder of the Riyadh Institute, which is a research institute from Vienna, Austria. We worked for quite some while in understanding all sorts of elements in relation to reverse engineering and in relation to verifiable things. So we're looking, of course, into blockchain, into Bitcoin and all the likes. But one core element of our work is revolving around open source culture and open source hardware. So you're very much invited to look up our publications. And we also made available most, if not all of our publications on our website. If you go to riyadh.at/POW, you can download all of our previous publications. And I'm not only active in the Riyadh Institute, I'm also active in a few other meta institutions and institutions, most notably the OSHWA, the Open Source Hardware Association, where I was a board member for quite some years. And this month is Open Hardware Month, so you might want to check out what the open source hardware events all over the place are. The whole month of October is filled with interesting events all over the world, mostly virtual events. Yeah, but jumping right into the talk, and just actually to give you a map of how to read my talk. So I have been talking in the past a lot about tactics to uphold cypherpunk values. Some of those are out in the open. You can still rewatch them. So for example, my last talk was during MoneroCon in Prague, which was about decentralized commons. And I was criticizing a lot how I believe open source culture has been enshittified in the past years. So I think Cypherpunk still has a lot of answers to problems that we see in the open source culture. Another example of Cypherpunk tactics, mostly revolving around reproducible software and hardware, verifiable hardware, was during HCPP 2019, opt-out with open and libre hardware. And I did a few other talks, mostly about open source hardware in relation to cryptography, in relation to Bitcoin and Monero, because that's my background. But generally, I will be talking today about scaling tech and scaling values, and there will be a longer talk during HCPP, Hackers Congress Parallelipolis, next week, where I will be talking and giving some more deep insights into what I call hardcore cypherpunk values. So you're very much welcome to join us there and to discuss further what I will be showing today. So I will be starting now to flesh out a bit scaling tech versus scaling values. And I want to start with the term scaling, because it's a quite interesting term, and it got me thinking, because everyone is talking about scaling Bitcoin, scaling the tech around us. I'm a technologist myself. I studied computer science. I did all sorts of different shenanigans when I was young. So I'm a self-taught programmer, also programmed since I was a kid. So scaling is all over the place, and I've seen so many technologies scale in the past years and decades. And scaling, though, is a process of simplification in order to optimize. So scaling is not only always creating better things. It's a very, to me, a very kind of dubious thing. I've seen cultures as well as technologies scale and fail. And so scaling technology, I want to explain to you how I see how technology can scale, but I want to also give a few examples that are maybe hopefully a bit tangible to understand like why scaling is always a critical process. So in the case of scaling technology, it refers to making systems by its definition larger, faster, or more efficient. And I want to make this distinction also because I will be talking about scaling values later on. But to achieve this scaling of technology, of a specific technology, of a set of technologies, we need to simplify the underlying systems. We need to identify what we can actually improve because actually it can be simplified to some extent because we need to identify optimizable parameters. We need to think, okay, how can we actually scale a system so it becomes faster, larger, or whatever we want to optimize for. And I want to give a quick example from the semiconductor industry in order to see, like, also that we can see examples or observations to show technological progress. And maybe the most famous ones is at first Dennard scaling, which was introduced in 1976 by Robert Dennard, which was actually showing how transistor performance scales with shrinking size to maintain power efficiency. So we see here on the right-hand side also that you see how the trends of that kind of scaling worked out. There is definitely easy observable that in 2060 stopped being the case. Not sure if it's so common sense, Dennard scaling, but maybe more well-known is Moore's law, which was actually postulated by Moore in 1965, where he was actually observing essentially that the number of transistors on a chip doubles approximately every 2 years. It was, in my opinion, a bit postulated as a joke, but it became Moore's law. It's definitely not a law, it's an observation about how technology scales or how semiconductor industries scale. And there's another one, Kumi's law. This was postulated a bit later in 2010, and interestingly, then almost a year later already proved to be not really working anymore. So this is interesting in all these kind of laws where you see, especially regarding the micro, like the semiconductor industry, that these things work to forecast, but only if you look at the past developments of transistors, because we are in a phase now that these things don't make so much sense anymore. And there's different reasons why this is the case. So these models held true for a long time, and they held true in the time when there was competition, when the market was a bit bigger. But to me, what's interesting is about the semiconductor industry too, and this is also why I'm observing this. There is such a forecast model. There's a model how to see how technological progress will be, and it worked for quite some time. It worked for multiple decades. So to me, it's interesting. Why is all that breaking down now? What happened? Was there something really happening that these things really broke down, or is it just like the way of how we observe things? So these laws, they're obviously not really laws, but observations, in my opinion, also documented centralization tendencies in the semiconductor industry. And I will quickly break down why that's the case. So as I said, all these laws somehow broke down between 2010 and 2015. And breaking down means like it doesn't really 100% apply anymore. So Dennard scaling, for example, hit practical thermal and power limits already a little bit before. And the interesting thing is, though, that it also shows that these laws somehow seem to have pushed the industry into a more centralizing direction. So I'm not saying that the semiconductor industry by any means is now easy to enter. It has the highest entry barriers of I would say the whole IT industry. You need a lot of money and need a lot of R&D budget. But all of these laws individually show us that there is some centralization that happens. So while all these things scaled, all the individual technologies and the players were becoming less. So one example with Moore is, of course, Jensen Huang, who is the CEO of NVIDIA, was saying that Moore's law is dead. But with Kumi's law, it's, in my opinion, even more interesting to see, because the slowing of Kumi's law has shifted the focus to more integrated hardware and software manufacturers. Here, very interesting to see, this is Apple that essentially is the centralizing force of the pinnacle, the vanishing point of Kumi's law is Apple. So why am I telling you all this? Just try to make a point that scaling technology works, and we have examples. There was just a few examples I've given you where people traced scaling technology, but scaling technology always risks centralization. And it actually maybe is the root cause of centralization. And another example, or a few other examples of successful scaled technologies that worked, but that somehow affected, or the effect of that was that there was more centralization is, for example, content delivery networks, cloud services, serverless computing, virtualization, all sorts of things related to cloud computing. So in my opinion, scaling doesn't just improve a system, it forces a lot of trade-offs you have to do. You have to think of, you have to design, you have to optimize for. And those trade-offs are often overlooked, and those trade-offs in the past have already fucked up our situation a lot as cypherpunks. So as I said before, a very, very tangible example, in my opinion, is the cloud. So the cloud somehow was a way of how to improve infrastructure, business infrastructure, and of course, being one of the most important centralizing forces of the past decades. I think the cloud is really a big problem for us as cypherpunks, and if we look at what the cloud does to blockchains, there is these recent numbers that around 60 to 70% of Ethereum nodes, for example, are running on the cloud infrastructure. I'm not entirely sure how many Bitcoin nodes are run on cloud infrastructure, but it's actually really, really advisable to make sure that our infrastructures are decentralized enough. Another example, software as a service, or Gmail in this specific case. So Gmail has a lot of active users. This is really insane. It's one of the most successful services. And my point is that Gmail really is a problem because Gmail centralized away the decentralized nature of email. And so that's also a problem, in my opinion. Did you ever try to self-host an email server? It's not easy that in current times. So in a way, Gmail created a way of scaling away email. And so my point to conclude with this first chapter is that cloud computing and software as a service have represented the most significant setbacks to cypherpunk values over the past decades. I'm letting that sink in. So yeah, I want to also talk about scaling as transformation because, as I said, scaling systems are, and scaling itself is a process of simplification and generalization. So a lot of complexity is generated, but you have to simplify in the first way in order to create another form of complexity later on. So you have to figure out what you want to optimize for. And I want to give a very different example that is a very statist approach. It's a statist way of understanding scaling. And in the book, Seeing Like a State, this is a very good book. I can absolutely suggest you read that if you haven't already. James Scott explains how to see like a state, or what actually scaling from a state perspective is. And his points are that, for example, always when states try to create control and control large amounts of people or space, they simplify complex and local knowledge into legible forms in order to exert control. And with that process, and I think that's a very good example to show us like why scaling is always this kind of reductive process. James Scott gives a few examples of why, how we can actually understand that. Like maybe a good understandable example is, for example, the metric system introduction after the French Revolution, where there was in existence a lot of different services and people and that did specific local businesses around the fact that there were so many different ways of how to count things and how to scale things. And these all got actually wiped away after the introduction of the metric system. There's a lot of other examples that Scott gives, but there's also, I hope this is making it a bit more tangible, why scaling is problematic. Another maybe more commonly known example is to scale teams. And I like that book a lot. This is actually taught in undergrad computer science, and I think people should read that book because it's fucking fantastic. This is Frederick Brooks' The Mythical Man Month. And so Brooks was explaining in the 70s in his observations, I believe he was working for IBM. He was developing different software projects. He was working with a lot of developers, and he always had this kind of problem that he needed to essentially describe his work in terms of man-month or man-hours. And his point was that was not actually how systems ever would work, because teams are not that easy scalable. So his point was also that if you add people to a software project that is already late, the more people you add, the later the project gets. So it's like not a linear scale, and teams don't scale in a linear fashion. And so what Frederick Brooks was explaining is that it's more effective to have like smaller teams that don't have so many communication channels. Actually, was showing and proving that the number of communication channels grow exponentially the more people you have working together. So it's also called the coordination problem that we know from other specific disciplines. We know it from game theory, we know it from different backgrounds. Coordination problem is a big problem. And the challenges that were postulated in 1975 led to this kind of revolution later on, sort of revolution that we have experienced as agile development, or we know as agile development. And for everyone that is into software development, they have worked for sure with agile. I don't have a particularly good experience with it. A lot of people say, okay, this is maybe over, this is done. It's like nobody is really that big of a fan of agile as a developer. It has created a kind of a term where people, developers specifically, work against project managers. I'm just showing you here that this is also a form of scaling. And we have seen that from specific other situations of specific other disciplines, from team scaling and from state scaling, we see the same problems. And we have even bigger problems, in my opinion, or it's even more complicated to scale decentralized technology. So decentralized systems, blockchain systems, like Bitcoin and Monero, scale very differently than the things that I've shown you, but we might have to look at the similar problems that arise. And so what I was asking myself is, how do values scale? How is this even possible? Is there some example in the past, like do values scale in some form? And of course, I'm interested in cypherpunk values, so I looked into cypherpunk values. And we have to firstly also attest that there is no real list of cypherpunk values. We don't have some kind of this kind of clerical situation where we go into the church of Satoshi and we see the list of the cypherpunk values. But of course, over time, there have been some core cypherpunk values that I believe everyone that is into cypherpunk or that somehow has studied cypherpunk will hopefully agree that there's these three core cypherpunk values, which are financial privacy, private digital communication, and avoiding government surveillance. But then there are broader cypherpunk values, and these are a bit more loose, so they came a little bit later. They were added, and as I started to research those cypherpunk values a few years ago, we also found that there maybe needs to be another distinction, another taxonomy also to understand cypherpunk culture, because I think like a lot of things get mixed up and mixed together, and it's really tough to draw conclusions. So we came up with this idea of creating phases of cypherpunk. And so we came up with these 5 different phases of cypherpunk, where it's a bit easier also to understand the scale of cypherpunk, the public perception of cypherpunk, and how this actually got perceived externally. So there's, of course, internal developments that cypherpunks did that were super relevant. Maybe technology was not fine enough for people to really catch on or to understand what's going on, and maybe it was really expert-oriented. So looking at those phases, essentially what we described is a foundational era, which is 70s to 90s, so essentially before the internet was popularized, before Firefox or any other browsers, Mozilla, sorry, essentially was out there. So we had RSA encryption algorithm and early cryptographic protocols. It's the very, very first things that were relevant to the cypherpunks. This has changed in the internet expansion phase because people started to actively use the internet. But what might be relevant in this context is to understand, okay, PGP was there, so this could be used already. So people started to use email and essentially any browser-related activities at this time, like in the early stages still. Decentralization focus would be from 2001 to 2013. This is overlapping a little bit also with the commercialization of the web, and then also Web 2 and all these different other elements, largely informed by the 9/11 attacks and the Patriot Act, which we believe is a very, very problematic time also, and a very crucial time also to observe for cypherpunk value shifts. Then we see one huge privacy resurgence, so some kind of return to privacy values through the Snowden revelations and other leaks. And then the last era, which is relevant, in my opinion, is the surveillance era. This is the phase we are in right now, which is the phase after COVID, because COVID forced a lot and brought a lot more people online. We have seen a lot of more digitalization as before. And so looking through these kind of lenses, we can maybe also understand the different scaling processes that I described before and apply them to cypherpunk, and then to see, okay, what is happening and what got lost, what got gained, did the scaling processes work? We started actually doing this for all the different values we could identify. I will not show all of that because I will be having a talk also next week during HCPP in Prague. So I just will show the first one that we did, which is like looking at the value of privacy. And we did also write a lot about this, so you will be able to get all the data. If you're interested, I can share this with you actually beforehand. Interestingly, if you look at the foundational era, privacy is really a core value to the cypherpunk. So this was very interesting to a lot of people at this point to have privacy. Although the public sentiment of cypherpunk at this stage and also everything posted was really, really limited. So the public sentiment was really niche. So people didn't really understand what cypherpunk was. Nobody knew what cypherpunks are. This has changed a little bit in the internet expansion phase, in the second phase, largely because of the crypto wars, because crypto wars got a little bit of attention online. I would not say it was like worldwide attention, but it was definitely US based interest and sentiment into, okay, there's something happening there, was starting to rise. People were not that aware of tracking over the internet, but we can actually see that this changed a lot in the decentralization focus phase in the third one, where incidentally also Tor got its first release in 2002, and 9/11 was the really important point in time where there was a huge sentiment shift in what people perceived. Especially, and this is interesting to me, that this jumped into some kind of immediately more of a security concern to people than they would have a privacy concern. So people would feel threatened by technology much more than they would feel like, okay, their data could be used to track them. This got actually really, really changed in the privacy resurgent phase, in the fourth phase. Mostly because of all the leaks that were happening. Snowden was actually publishing his leaks and everything, that people suddenly understood, okay, there's really something happening. And when I say people, I mean like the broader masses. The cypherpunks, of course, knew that these things were going on. But we can see this and we can trace this also in the surge of use of Signal, WhatsApp, and the sort of encrypted applications that were out there. This is actually provable. And in the surveillance area, the area we have now, we see that the general discourse also about privacy and security tends now more towards security. We have an absolute insanity of surveillance, and people start to get aware, but people also stop to care, in my opinion. So the public sentiment is really, for the current era, it's a bit problematic. So we looked at a few other of these cypherpunk values. I'm just showing the ones that we identified, which is decentralization, anonymity, freedom of information, and the likes. autonomy and self-sovereignty. So we created all sorts of like different visualizations around that. Resistance to authority. I want to quickly talk about the dilemma. What's the dilemma now for cypherpunks that we are into? So in a way, cypherpunks and the cypherpunk movement was instrumental in creating a lot of the technologies, encryption technologies, things around us that are considered normal, like secure communication, end-to-end communication, and so on. But the problem is that scaling technology was somehow working. So there is now also cryptography in the hands of everyone, but we have not really scaled the values. Some of the core values are still a problem, or a bigger problem than they were 30 years ago. This disconnect somehow creates a big, significant dilemma for cypherpunks today. And just again, to show this a little bit and to make this a bit more tangible, so we have a dilution of the values. So some encryption tools, blockchain, Bitcoin, these tools are everywhere. But still, the problem, the core values of anonymity, for example, are not really given. So it's really tough for people to be anonymous. So everyone has cryptography technology in their hands, theoretically, but there's also no way for them to show or to understand if there's not a backdoor inside. So as I was showing in the beginning, also with the semiconductor industry, it's actually impossible for a normal person to identify if you have a hardware Trojan on your hardware. There are a lot of documented forms of hardware backdoors, especially if you look into recent reveals from Intel and AMD. The problem is just, do you know that nothing is happening? No. So the problem is essentially we have a lot of technologies that got appropriated, that everyone is using, but the initial values of the cypherpunks to be able to verify your systems is not possible, it's not given. And I want to also clarify here, so I mean the adoption and integration of the underlying values into broader society, they have not kept up, so of course the values are still the same. So the values, in order to keep up, would have to scale as well. But this is also tough because, of course, technology moves quick. So how can cypherpunks react to that? So I think we have to think of how to reevaluate the values that cypherpunk stands for, and also try and get. I mean, there's all these kind of traps for people. I'm sure you heard of the privacy versus convenience problem. So it's often the main argument and the killer argument that I'm not using this system, a specific system, because it's not convenient to use this. So producers of software try to make conveniently secure or private systems, but this also didn't really work. So we have to find an answer for this type of dilemma. So I would end with this slide to say that the cypherpunk dilemma today centers around bridging the gap between scaling technology and scaling the core values it was founded upon, especially privacy, anonymity, decentralization, and individual autonomy. And we have to empower individuals and actively promote and embed cypherpunk values into the society. Thank you.
Yay! Preach to the choir, preach to the choir, preach to the choir. Technologically, what's the most interesting thing? What's the most interesting thing happening right now, and what's the most challenging aspect about cryptography and how it is that we use it?
Do you mean for me, or for what I observe for cypherpunks, or?
Generally speaking. So it's first a social question, and secondly, it's a leading question about the technical aspects.
Yeah, so I think what's interesting, and I'm happy to see much more systems emerge that do that, is verifiable, all things that you can verify. I feel like we lost the way to control and to verify the systems around us, and so I'm always happy to see that this is the case. There's also a few interesting tendencies into new communication protocols, like truly anonymous communication. I feel is not something that we have at this point. So even with Signal, there's a lot of critique about the current way it's implemented. Definitely the question is always like about the threat model, so people are not really aware of the threat model, but I think it's a lot of interesting developments out there that are maybe not so much in the spotlight because they are started by a small group of developers or individuals. The problem that I personally see in the open source world is that a lot of the really interesting projects are underfunded massively, and so they stop just working on projects. So that's the biggest problem. So I'm excited to see that people are excited and to really work on new protocols and really to try and dig into the weeds and not take everything as a given, but try to reinvent or try to look twice if we can solve really basic things in a secure way.
You spoke to me about the upcoming cluster at CCC camp this year, and you also mentioned that there's a generational gap. Would you like to expand on the challenges there in knowledge transfer and motivation?
For sure. So yeah, I think it's a huge problem and huge knowledge gap in crypto at this point. And crypto, I mean like cryptography, not Bitcoin or cryptocurrency, maybe there as well. But the problem is definitely, especially looking into why people contribute to open source, you see a big different motivation, especially from younger people. So a lot of younger developers don't like jump quicker to specific forms of code licenses, for example. So there's, for example, a lot of the younger audience or younger people don't even know that there's something beyond GitHub. So GitHub becomes the somehow only place where open source exists. And I believe this is maybe also because we've seen in the last years a bit of a change in how people work. So everything becomes, I think this might be also through COVID, I'm not entirely sure, but I feel like the places of exchange, they have been becoming less. So we don't see like a lot of real life kind of events anymore.
Hackerspaces and makerspaces and groupings
are completely gone. So it's like it's insane how they completely vanished. And let's not forget that the Bitcoin culture was actually born in hackerspaces and these type of places. So I think that's super important to keep up those kind of places and to make sure that they exist and that these kind of real life kind of exchange happens. So I think that's important.
I've both read and heard that sort of like the hacker culture in Ethereum is even sort of like people are saying it's dead, that sort of aspect.
That's very interesting.
Yeah.
Why do you think that is the case?
I think that that's a comment about how it is that all of the infrastructure funding projects across all of the different competing chains for developers are offering economic incentives, and that results in a mercenary sort of like, okay, we're going to go here because that's where the money is, and it's not really like the social activity with social glue that it used to have as hacker and maker culture, I think is the criticism or the argument. Do we have questions for Matthias? Yeah.
I have one question. You did mention some scaling concerns involving Monero. Would you like to elaborate or expand on that particular issue?
Thanks for the hard question, Francisco. Yeah, I think any scaling process, as I was trying to outline in my talk, has some form of loss inherently. So you're optimizing, you're simplifying, and therefore something is lost in the process. So I don't have a particular concern about the current scaling issues or tendencies of Monero, because I think there's a lot of interesting and, in my opinion, really good decisions being made in Monero, and also looking at how, for example, Monero, in a way, solved the problem of a potential centralization in the mining sphere through RandomX and a few other things. That was really, really very interesting and should actually be an example for other cryptocurrencies as well, in my opinion. So I think generally what I liked as well with a few attempts where Monero community identified, okay, there could be some centralization happening, that there was a verifiable and like very transparent discourse around that. So that was really great to observe, also as a researcher, to understand like that the community is able to reflect upon that. I see that also very much existing in the Bitcoin ecosystem. So that's really nice to see. Of course, some other smaller ecosystems don't run into that problems because they're not at that scale yet where this becomes an issue. But yeah, so sorry to not give a direct answer to this. I don't see any problem with the scaling attempts of Monero at this point.
Matthias here. What was the youngest cypherpunk you met that resembled those values that you were manifesting?
You mean that I accounted where, like in my life? You mean?
Yeah.
So I think like definitely, for example, in the cluster. So we are organizing this this cluster. It's called Decentral Community every year at the annual Chaos Communication Congress. So we had a very young kid from one of the Monero developers that was giving a workshop on Monero for kids, which was awesome. This was in 2019. I would consider this kid to be in Cypherpunk. I think he was 10 at this point. So that was really fantastic. So I really think it's important for younger generations to be able to understand these kind of things. And I think especially if you're like interested and curious in these topics, you can, as a kid, understand that, for example, it's bad, like surveillance is bad or has some kind of problems that need to be countered. And so actually these topics we are fighting as cypherpunks are really, really easy to understand. So I believe that kids are really a good target audience, so to say.
Hey, I'm wondering if you've had a chance to explore or have any leads on like where to learn from how to propagate values further, right? So like, you know, two examples come to mind as maybe like civic nations had to build extended kinship ties based on, you know, however you do nation building, or even like lifestyle brands like create like an identity that then you associate with social status and the product. I don't know how you're thinking about that at all.
That's an amazing question. So I think like essentially we have to, like what I'm always observing is that, like observing myself, is also that I feel like I lost control of all the technology around because I don't know what's going on. So this is actually posing a lot of problems for people that are curious, because then it takes you a lot of time to disassemble things, reverse engineer things, understanding what's going on. And of course, because of the microcomputing age, we cannot do that anymore. There's a huge movement, though, that tries to bring that back, to have like verifiable hardware, for example, verifiable software. These things are out there. We just have to understand the potential of that, and we have to maybe re-implement some of the core principles and core algorithms a little bit differently, because most of the stuff is not really optimized. So I mean like really basic cryptographic algorithms could also be reinvestigated and made sure that they work on slower hardware, for example. If we could make that happen, we can maybe, for example, use Mega65, which is a super open source C64 clone, and do cryptographic procedures on this. I think that, this is a good example, in my opinion, because you can completely verify the chipset. You can see if some shenanigans has happened. So it has been created in a production size that you can actually still visually inspect this with home lab equipment. So I think what's important is to also understand that doing these kind of inspections and these kind of visual inspections on stuff, on hardware, software, of course, as well, is not expensive. I will have a talk this year at the Chaos Communication Congress in our cluster, where we'll be showing, for example, a lab that we were working on in the past years. It's based on SIGROC, which is an open signal processing software on Linux, and we have made this available. We open sourced all the things to actually have your own hardware lab where you can inspect hardware, verify hardware, and find out what's going on. I think that's the problem, that people have this kind of fear that they cannot use and understand what's going on. So I think we have to take away this fear and like really educate that people know that they can really look up what's going on and really open devices, reverse engineer devices, break devices. So I think that's the approach.